Good day, viewers at home. In case you are hearing my voice for the first time, my name is Engineer Will.I.am plus S. In our today's class, we shall be looking at scalar and vector quantities. So what is scalar quantity? Scalar quantity are simply physical quantities that have magnitude but no direction. So another word for magnitude is simply size. It has size but do not have a direction. So example of such quantity include mass, time, speed, area, work, energy, power, etc. So these are examples of a scalar quantity and many more. So they are quantities that have magnitude but no direction. Then the next type of quantity we have is vector quantities. Vector quantities. What are vector quantities? Vector quantities are physical quantities that have magnitude as well as direction. These ones have size and also have direction. Examples of vector quantities are velocity, acceleration, force, impulse, momentum, and many more. So these are few examples of vector quantities. And that you should know is that a vector is usually represented with an arrow-headed line. A line that has arrow at its head is used to represent a vector. The length of the line represents the size of the vector, while the arrow represents the direction of the vector. So as you can see in this direction, in this particular question, I have two vectors. But these two vectors are moving in opposite direction. So this one is moving due east, whereas this is moving due west. So this is a vector because it has size and also has direction. That is how you represent vector. Okay, let's go to the next thing. So the next thing we look at is how do you find resultant of vector? But before that, what is resultant? Resultant is that single vector which when acting alone will produce the same effect as two or more vectors acting together. Vectors when acting alone will produce the same effect as two or more vectors acting together. It's called resultant vector. We have several ways at which you can find resultant of vectors, which I am going to be explaining one after the other. The first thing you should know when you find the resultant of vector is 1. When two vectors are moving in the same direction, to get the resultant, you just sum it up. That is, you add the vector whenever they are moving in the same direction. Just in this case now, these two vectors, let's say this is vector 1, v1, and this is vector v2. Vector v1 and vector v2 are moving in the same direction. So whenever two vectors are moving in the same direction, you simply add the vectors to get the resultant. So the resultant here will be v1 plus v2. You add it up. That is when they are moving in the same direction. The second thing you need to know is that when two vectors are moving in opposite direction, let's say these are two vectors moving in opposite direction. So let's say this is v2 and then this is v1. They are moving in opposite direction. This is moving due east and this is moving due west. So whenever they are moving in opposite direction, If you want to get the resultant of this vector will simply be the difference between the one with the higher magnitude and the one with the lower magnitude, which will give you v2 minus v1 if v2 is greater than v1. Or you can say resultant is equal to v1 minus v2 if v1 is greater than v2. So you are removing the smaller vector from the higher vector. Number 3 case is when two vectors act at right angle to each other, you simply use Pythagoras theorem to find the resultant. When they act perpendicular or when they act at right angle to each other, you simply use Pythagoras theorem to find the resultant. So let's say you have a vector. This is also a vector. This is vector v2 and this is vector v1. As you can see in the above, the angle between the vector is 90 degrees. So that is what I mean by perpendicular or at right angle. So if the angle between the vector is 90 degrees, simply use Pythagoras theorem to get the resultant. So this becomes the resultant. So here is the hypotenuse of this triangle. The longest side of the triangle is known as the hypotenuse. Then here is the opposite and here is the adjacent. Though the opposite and adjacent are not always constant, but the hypotenuse is always constant. So if I have theta here becomes opposite and here becomes adjacent. Here becomes hypotenuse. But if I have an angle here, if I am considering this angle, here becomes my opposite and here becomes the adjacent of this particular angle. So you can use this to find resultant of vectors. Saying resultant, applying Pythagoras theorem, resultant will not be v1 square plus v2 square. So this is the Pythagoras theorem. The sum of the square of the opposite and the adjacent is equal to the square of the hypotenuse. Pythagoras theorem. Let's take a few examples on that. But before that, there's other few things you need to know. And what is that? From the diagram above, the longest side of the triangle was my resultant, but it's not always the case. For instance, if you have a triangle, let's say you have this. This is still a right angle triangle. This, and I have, so let's call here P, Q, and R. So we're having three vectors here, vector P, vector R, and vector Q. So how do you determine which is the resultant? So the resultant of these vectors here is simply the one that is moving in opposite direction. So from the diagram above, two of these vectors will be going the same direction, but one goes in opposite. This particular vector, vector R, vector Q, and vector P, one among the three moves in opposite direction. So that which moves in opposite direction is our resultant. Let's see how you can analyze it. If you can easily get it by saying, if you look at the arrow of the resultant, you can see that this and this are going the same direction, but this is going in opposite direction. Or you can make it cyclic to make it more clearer. Let's say I start with a P. I make it to form a cyclic compound, cyclic vector. Here is P. So where the P start, let my Q start, continue from there. I now have Q here. You can see the arrow of the Q. And I complete it by adding the R. You can see the arrow of the R. So here is R, here is a Q. So between these three arrows, which one is going in opposite direction? P. So your resultant vector will be equal to P equal to R plus Q. Or you can say P is equal to Q plus R. So this is the resultant. So the one that moves in opposite direction is our resultant vector. That's our resultant vector. So let us take some examples on resultant. Example 1. A man walks 1 kilometer due north, and then another 1 kilometer due east. Calculate his displacement. Calculate his displacement. So what do we do here? We are asked to look for the displacement of this man. The first thing you consider here is displacement. Is it a vector quantity? The answer is yes. So since displacement is a vector quantity, we are going to be looking for both magnitude and direction of the man. We start by analyzing it, drawing the diagram for his movement. First of all, the man walks 1 kilometer due north. So you can use your cardinal point. Let me just quickly draw the cardinal point before I go into that. So the cardinal point we have is majorly 8. Here is north. So if you are moving upward, you can say you're moving due north. Here is east. If you're moving towards your right, you can say you're moving due east. Here is south, and here is west. So in between north and east, I have northeast. In between east and south, I have southeast. Then here I have southwest, and here I have northwest. So these are the 8 cardinal points I am going to be using to explain this particular topic. So what do I do next? What do I do? So I come here and say a man walks 1 kilometer due north. So due north should be this direction. I have to put the arrow, and make sure you indicate your starting point. So this is the starting point. So this is 1 kilometer. So after traveling 1 kilometer, what did he do? He changed direction and moved due east, which should be this direction. 1 kilometer. And we're asked to look for the resultant. So the resultant should be the hypotenuse here, which the arrow must move in opposite direction to the other ones. So this is the resultant. And if you look at the resultant now, and this is your cardinal, it is around northeast direction. Northeast direction. So if it was here, you can say northwest and thereabout. So resultant square will give us 1 square plus 1 square. So the resultant square will give us 1 square should be 1 plus 1, which will give you resultant is square root of 2. That is kilometer. That is the magnitude, remaining the direction. So the next thing, how do you get the direction? The direction of the resultant, though we already know the direction of the first vector, which is north. We also know the direction of the second vector, which is east, line 180 degree, and this one is line at 90 degree. So how do we get the direction of this particular resultant? The direction of this resultant is simply the angle between the resultant vector and the starting vector. This angle, the angle between this resultant vector and the starting vector, which let me call it theta. So here I can now use SOHCAHTOA to get this. That is the abbreviation for the trigonometrical ratios. So I can use tan theta, which is opposite over adjacent. So that tan theta will give me what is the opposite of this angle. The opposite of this angle is 1. And what is the adjacent of this angle? The adjacent of this angle is also 1. So 1 divided by 1 will give me 1. Then I now take the tan inverse of 1. And tan inverse of 1 is equal to 45 degrees. That is the tan inverse. So if I compile my answer now, I'm going to have the magnitude is root 2 kilometer north 45 degree and east. I believe you know I get northeast from. That is the direction of the resultant. This is the answer to the question. This is the magnitude and this is the direction. In our next class, I'm going to solve a few more questions on that.